Okay, I'm Pippa Spencer, Certification Technical Lead at Rolls-Royce. So I'm here to talk to you a bit about what Rolls-Royce do and a bit about what I do. So I'll start with a bit of audience participation. Hands up or shout out, what does Rolls-Royce do? Jet engines, excellent. So slight trick question. A lot of people think Rolls-Royce make motor cars. The Rolls-Royce that makes motor cars is now owned by BMW, so Rolls-Royce itself don't actually do that. But yes, we do actually make jet engines for aeroplanes, passenger carrying aeroplanes. That's not all we do. We make engines for the fighter jets. We do the vertical lift systems for the F-35 Lightning. We also do nuclear power for nuclear submarines. We do shipping as well, so engines for a lot of the large marine ships. We do autonomous shipping. And also the large diesel engines for a lot of the trains. So we do quite a lot of stuff, but most famously known for its aero engines. We do also do cars, but being Rolls-Royce, we only do the best type of cars. So we do the Bloodhound supersonic car. We actually do the engine for that. Okay, so I'm Certification Technical Lead for Trent 7000. So what does that actually mean? So what is certification? So a bit like in nuclear, in the nuclear industry, we have to prove that our aero engines are safe to fly. You wouldn't want to go on one that hasn't been tested or verified. You want to know it's safe, and when you get on there, you're going to go from A to B without any problems. So certification is the process for showing that our engine meets the regulations and the requirements and is safe to fly. It's a major business milestone, so we can't do anything else without certifying. We can't go onto a flight test campaign without certifying, so we must pass that. And quite simply, like it says, you get a certificate at the end of it that says, your engine is safe to fly, Rolls-Royce, thank you. So what is the Trent 7000? So this is a brand new aero engine. A lot of you in the audience might know a thing or two about engines. So you might have heard about the Trent XWB, Trent 900. They're all flying ground in service at the moment. You might have been on some of these aircrafts that have these engines on. Trent 7000 is not in service yet. This is a brand new aero engine. It's a fast-paced project, so we're doing it in the shorter timescales than we've ever done any engine project before. And Rolls-Royce will be the sole supplier of engine for the A330neo aircraft. So that is an Airbus aircraft. It takes the old A330 aircraft, and as it says, NEO stands for New Engine Operation, so a brand new engine on that aeroplane. Okay, so I've talked a little bit about the A330 and Trent 7000. It might mean next to nothing to you. So, as I said, the A330 is currently an aircraft in service. It's powered by Rolls-Royce Trent 700 engines. I've been on one between Manchester and Philadelphia to the States, and that's in service. But Airbus want a more efficient engine, they want a more efficient plane, they want more passengers to travel back and forth on it. So they've teamed up with us, Rolls-Royce, to come up with better engines. So we're taking that capability and that technical knowledge that we've used on the Trent XWB, which is the most efficient aero engine out there. Trent 1000, which powers the Dreamliner, we've taken a lot of that technology, and we put it all into these new Trent 7000 engines. There's going to be 2 of them on the 330neo aircraft, and that's really the biggest change to that aircraft. Airbus are making some tweaks to the wings to make it more efficient. They're changing the cabin inside, so it'll be more modern. You'll probably notice it more if you're lucky enough to travel first class, but for us in economy, mainly minor changes. But it is a wide-bodied aircraft that will travel long haul. The Trent 7000 engines are absolutely massive. I was lucky enough to be in the shop where there was a 7000 next to a 700 engine, and they are absolutely massive in comparison. So there's a larger fan diameter. Reason being for that is it rotates slower, pulls in the same amount of air, but is a lot quieter. So for those poor souls who live near Manchester Airport, Heathrow Airport, it'll be a lot quieter for you. Okay, so why do we have to certify? Anybody? Sort of already talked a bit about it. Shout out. Safety? Yeah. Okay, so not for any of these reasons. So first class tickets too pricey, seats are too small. No, these are just all our customer complaints. The reason we have to certify is to avoid incidences like this. So these are historical incidences. Some of you might remember them, some of you might not. And a small failure in the engine has caused a catastrophic failure overall. So there's one in the bottom there, which is Boeing 737 at Manchester. Disc failure led to an engine fire. The pilot turned the aircraft the wrong way into the wind. The fire burnt through the whole of the cabin, lost all the passengers on board. So safety is really the number one priority at Rolls-Royce in what we do, and that's why we need to certify. There's some other incidences there. Pilot shut down the wrong engine after a fan blade issue, so how can we avoid issues with pilot intervention in the wrong cases? Because it does happen. It's not perfect. These things do happen, but we're getting better. We're learning from our experience on the incidents that are out there, and regulations are getting harsher and tighter, and Rolls-Royce comply to them. So as I've said, quite simply, certification is focused on safety. Number one priority is to make passenger flying safe for all of you. In recent years, certification also addresses emissions regulations and noise regulations, which have gotten harsher. And actually, every country has its own regulatory body. So EASA is the European one, so Rolls-Royce will certify with the EASA. FAA is the American one, so if we want to fly in and out of the States, we also have to what we call cross-validate with the FAA. And every country will have their own, but EASA and the FAA are the two big ones. Okay, so we've got to show that the engine is safe to fly. So how do we do it? How would you think we could do that? Shout out.
Material selection.
Okay, material selection. What else?
Testing in rigs.
Testing, yes, brilliant. So lots of ways we can do it. So we could operate our engines for a long time in service. So Rolls-Royce has got a lot of history, a lot of planes out there. We do actually build on that experience and say, okay, well, Trent 1000 actually hit a milestone this year on the Dreamliner, 1 million flying hours. That's a lot of experience that we've got. So we can take that and say, well, the technology in there is good, it's safe. Can't rely solely on that. So we'll do some detailed analysis. Analysis methods have gotten better, so lots of models. Instead of doing tests, we can model things these days. It's cheaper for a company, but it's also good because we're demonstrating new capability. Rig tests, as you said at the front, we do lots of rig tests. So fire testing is actually a rig test. So we won't set fire to a whole engine, we'll set fire to small components around the world in our rigs. We do whole engine ground tests, and that's where we'll put the engine through its harshest conditions, so harsher than it'll see out in service. So we'll really put it through its pace, get it up to max takeoff, max continuous. And that's where, when we strip it down and lay it out, we can see issues with all the components. But as I said, harsh test, you expect to see some issues, so it's all about, is that what you would expect to see from experience? Once we're happy, we've done enough of that, we'll stick it on a plane and do some flight testing. So that's before any of you get on it. Our Trent XWB did a flight test last week, took off for the first time, so a good milestone for that project. And we'll do some of our altitude testing. So we'll fly through certain weather conditions. We have to do a lot of icing testing to check that the components still work at those temperatures. Another type of test we do, which kind of links to the title of the presentation, which is avoiding turkeys, is the bird ingestion test. So why would we want to avoid birds? Well, a plane traveling at about 200 miles an hour, if that hits a bird, can do some serious damage to the plane and the bird. So we have to show that actually when the bird hits that aircraft, it's not going to leave a hazardous effect. So some of you will know that picture. That's back from 2009. Miracle on the Hudson, they named it. So a flock of geese took out that aircraft. The pilot glided it into the Hudson River very successfully. But that just shows that actually when these things do hit birds or conditions that, a whole flock of geese are not quite accounted for, these things can still happen. So my next slide is not for the faint-hearted, so if you are squeamish, I suggest you look away. So this is a Rolls-Royce bird ingestion test. So we fire animals at the engine, chickens, slow motion. It's the largest food processor in the world, and slow motion. So you might notice a bit of deformation on the blades, and you might see it through the engine, but overall, no hazardous effects. Okay, so these pictures are from damage caused to a plane from hail strikes, rain and hail. So you might not think, oh, hail's not that dangerous, we walk out in hailstorms. Traveling at high altitudes, it can be pretty hazardous. So we do a lot of rain and hail testing as well. And that's pretty much the end of what I had to say. Thank you for listening.